All right, today we're going to talk about how you can differentiate between mechanical noise and electrical noise on your quadcopter's gyro. Check out the image on the right. And now, is that electrical noise or is that mechanical noise? Well, let's pop in, look at a couple examples, and make you a black box ninja so you can tell the difference. To get right to the point, that is electrical noise that you're seeing on the gyro. The indicators are the vibrations you're seeing in the raw gyro signal that are tied to 0% throttle but a huge amp draw at the same time. That's because the motors are spinning up to arrest or enter into a move. And you shouldn't see a large spike of mechanical vibrations in that kind of scenario. But typically it's not just one spot of the log that you're looking at. It's a compilation of evidence that you're kind of building, and you can tell if it's mechanical versus electrical noise that's causing the vibrations in the gyro signal. Now, it's important to recognize in this subject that when a gyro, the MEMS gyro, is reading the rotational speed or any vibrations that it's seeing, it's really reading an electrical differential on a 3.3 volt rail. So when you're seeing the signal come back and there's a lot of vibrations in it, it is somewhat hard to tell if that is just electrical noise on the 3.3 rail causing that, or if it's actually the MEMS moving because of rotation or vibration that's causing that vibration that it's detecting. But there is clues you can look for. So let's go through a bunch of examples of what electrical noise looks like in a variety of different ways, so you can see it's not just one smoking gun. You kind of got to build this evidence, and things can look different depending on the log trace. So to get started, what do we really look for in flight before we even look at black box for maybe some potentials that we might have some electrical issues? So to get right into it, what I generally look for is if it's an unexpected rough ride. And you can see in this flight when I do full throttle punches, I have a sound build, sound motors, Zing motors. I know this frame is tried and true frame. And it was a new build, but it was unexpectedly rough. And I didn't understand why. Again, I had good props on there. Everything seemed sound mechanically. This is not the first flight. This is after putting it on 48 kilohertz just to see if that helped improve things. But just an unexpectedly rough ride. I didn't understand what was really warranting that. The other thing that you want to look for is, of course, any flickering in your OSD screen or in the video feed you're getting if you're on analog. If you see that, you can see some of the horizontal lines there a little bit, then that's kind of an indication there's a lot of electrical activity going on that's interrupting the VTX at least as well, which is generally on the same power rails. The other aspect you want to look for is if you start to do rolls and flip rates and it just seems like they're a lot faster than you would expect from your normal rates. I'm sure you have a feel for your normal rates when a roll or flip is supposed to end, and if you're kind of overshooting, that's also an indication, because with the electrical activity when the motors are ramping up and or braking, that can send additional pulses as the D terms kind of getting freaked out because all the different gyro electrical noise, and it is ramping the motors a little bit too much, and they're just not consistent in their output for either kicking into a move or stopping a move. Now you can see on this one, it was just, again, generally a rough ride, smooth forward flight, just kind of ramping up throttle, had the horizontal lines as well. So there was a lot of indications that something was awry. And of course, the best way to figure that out is through black box logging it. So that's what we did. Turned on gyro_scale debug and got a log of this, and then started to peel that back, because I really wasn't positive about if it was electrical or mechanical until I really started peeling back the log and trying to build that evidence to kind of see what was what. So this is the log from that specific flight where we just had. And you can see here when I go up to full throttle, that's the vibrations you're seeing, that it was kind of, the nose was juddering up and down. And you can see there's, some on the roll, but the pitch and yaw are distinctly different from the roll axis. This was kind of motor frequency vibrations that we'd expect to see. So if I look at the spacing of those, I kind of zoom in here, just hit M for mark point and then go to the next spot. They're 425 hertz. That makes sense. Specifically in this condition, I'm not entering any inputs here. So it's just full throttle. So 425 hertz, that's what I would expect to see for the vibration of the motor itself oscillating back and forth in the props. And all four motors are generally doing the same thing. But you can see here on the roll, I don't see that same thing on the pitch and yaw axis. Well, you really should. You should see the same consistent pattern of vibration on all three axes. And if you don't, that's an indication that one axis is seeing electrical noise versus another. So that's basically one piece of evidence so far. can see these little micro vibrations within here. That should look the same on all three axes generally. This to me is the main smoking guns for any electrical noise over mechanical vibrations. You can see right here through this roll move that I get pitch and yaw axis noise, but I don't get noise on the roll axis itself. So entering this move, the motors on the left-hand side are spinning up, and then they're braking right here to exit the move. And you can see these vibrations peak when the motors are peaking up and down. So let's add a couple things onto the trace setup we see here to see if we can help differentiate what's what. So if your ESC or flight controller has a shunt resistor, a lot of times the ESC does, and then it takes that amp reading back up into the flight controller. You can go ahead and add amp draw. So I'm going to hit graph setup on the pitch axis here. I'm going to specifically add that. I'm going to hit the plus there and then go down to amperage. And then I'm going to go ahead and make this really dark. So I'm going to take the line weight and make it 5 instead of 1. And you can see the amp draw specifically right there. If I look in here, you can really see that when that amp draw is spiking up, that's where I'm starting to get the electrical noise on the pitch and the roll axis both times. Of course, what you want to do is scrub through the log and see if you can see that consistency and pattern, that when the amp draw is going up, even though you may have 0 throttle or you might be on the throttle as well, that you're starting to see that nose profile and the D term really build on a specific axis. That's an indication, again, that you have an electrical issue. Now, the two things together are key because obviously amp draw means you're just higher throttle percentage in some cases. So if you have mechanical vibrations, that could just be, your props are really off balance. But again, if you don't have the consistency on all three axes, you should see that same vibration on all three. If you don't see it there, but then you do see this symptom as well. So those two things kind of are pieces of evidence together that you need to consider. Again, here I don't have consistent noise across the three axes, and on 2 of the axes, every time the amp draw goes up, there's vibrations added. And in some cases, I'm even at 0 throttle. Now honing in on this one specific section, you can see I'm doing a forward flip in this spot, and my amp draw is spiking up at a couple spots, but my throttle is down at 0 this entire time. So look right here, you can see the throttle is down at 0, just a forward flip. Also, if I go ahead and click on that axis to just highlight into that, and I can widen this out a little bit, you can see I overshoot the target. So this is my target roll rate, but you can see that my degrees per second, I'm really rotating at 1500 degrees per second, which my target is only 1000. So I'm 500 degrees per second faster rotation than I really want to be. And that's that, again, the motors are hyperactive going into this roll, and it's not braking or dampening, and it's kind of sporadic all over the place. It shouldn't be doing that. So if you have that symptom as well, when you're kind of steady in the roll or flip, that it's overshot the target that by that much and kind of holding on to it specifically with the high amp draw, that's also another piece of evidence. Finally, when I'm looking right here and I see these big juts going up and down and they're very sharp, so it's kind of looks like a vibration through here, and then you get some sharp vibrations, again, specifically as this amp draw is going up, and then they kind of smooth out again. That's also some evidence. That's not a smoking gun without these other things, but all these things in this specific log kind of get added together so you can come to a conclusion. Now in that last example, that was probably one of the toughest quads I had to troubleshoot to determine whether it was a mechanical issue or an electrical issue or something with the gyro, which between the electrical issue or something with the gyro, that is even a whole nother level. It's really hard to tell if it's just a capacitance problem or a gyro issue, and really you're just gonna have to swap out stuff like put a different capacitor on or put a higher rated capacitor on. If that doesn't work, then ultimately a lot of scenarios I've seen, you just have to replace the flight controller board altogether, and that does solve the issue. I don't think I've troubleshooted one yet where swapping out the capacitor actually solved the issue. It was always just the flight controller needed to be changed. Either the gyro was bad or just the flight controller design was not very good and didn't have enough electrical isolation on the 3.3 rail, which powers the gyro. However, sometimes you do get some smoking guns, and it's very easy to tell if it's an electrical issue versus a mechanical issue. So let's take a look at one of those. Now in this example, on the roll axis, you can see this massive spike that goes up right here. That is definitely an electrical issue. And as soon as you see something like that, where just the raw gyro signal just spikes way up and comes way back down, that's definitely an electrical issue. It's either not enough capacitance or the flight controller, something wrong with it. Is there something wrong with the gyro? Again, 9 times out of 10, you just have to replace the flight controller and the issue will go away. But you can first, if you have some extra caps, try putting on a bigger capacitor or flipping out, or just checking the leads on the capacitor. Sometimes I've seen it that the leads are, come desolder or have a cold joint. So resolder those, and sometimes that addresses it. Actually, in one scenario, that was an issue where the leads to the capacitor were kind of broken off. They were kind of touching and not kind of touching. And once I resoldered it, then it solved the issue. On this same quad, you can see it right here as well. You can see how we really go off track, and then we come back up and kind of overshoots and oscillates, and it's just kind of all of a mess as it's trying to exit this move, and it's real shaky and juddery, and you can probably hear it in the motors. Once you start to see that kind of stuff, again, definitely electrical issue. In this example, I got a screenshot of this a while ago, but this was probably the biggest smoking gun I've ever seen, where we were up at 1,000 degrees per second. It went down to 0 degrees per second and back up to over 1,500 degrees per second up here, all within a couple milliseconds, which just is not physically possible, of course, for the quad to do that. Even for something to vibrate to that degree, it's just not possible. The quad is rotating at 1,000 degrees per second. Even if something is vibrating off, it's not going to rotate. It's not going to vibrate so bad that that one piece would stop. I mean, we're talking about the gyro itself would have to stop. So it's almost like the gyro would have to become disconnected, stop rotating, and then rotate back to 1,000 degrees per second, like get reattached to the board itself. So just not physically possible. Definitely smoking gun. You don't have to have the 3 pieces or 4 pieces of evidence. You see something like that, it's typically a flight controller board issue. You just need to replace it. So now let's move on to mechanical noise, but mechanical noise that's not good. It's kind of bad mechanical noise, or it's okay, but it's leaning more towards mechanical noise. There's no smoking gun or pieces of evidence that are compiling together to tell me that it's an electrical specific issue. So in this log, you can see here we have noise on the roll axis and the pitch axis. Not too much on the yaw though. So we have 2 axes that are consistent. They're not that great. The yaw axis doesn't show much vibration at all. Yeah, notice here I do have the expo turned up. But they're both showing about the same frequency and vibration here as well. So you can see that the little ups and downs here are just kind of mimicked down here. It's just a little bit more amplified on the roll axis than they are on the pitch. It's not like they're showing 2 different frequencies where the vibrations on one axis are up and down real quick, and then the other axis they're kind of drawn out more and just much more erratic. There is some spots where there's a little asymmetry going on here, but I don't see anything specific on this. Looking at these traces that are telling me there's some sort of electrical issue specifically. When I'm looking at this one here, there's a move where it goes down to 0 throttle, and then he hits hard right. And you can see the vibrations on all 3 axes are low in that scenario. So the motors are spiking in amplitude with amp draws going up as well. So let me turn that on. So going back to this and looking, you can see here, turn to amp draw on the top row of axes here, and you can see that my raw vibration, since I'm at 0 throttle on the roll axis, pitch axis, and on the yaw are low. I do have amps spiking up here to enter and do different things in the moves as he's moving the sticks around, but I don't see a corresponding spikes on other axes like we saw and talked about before. So again, these are not great vibrations. There could be, the props may be problematic. That's the first spot I would look there. And after that, it's typically like a frame issue. Sometimes the frame starts to delaminate, or just as a bad frame design. I would definitely put on different props. Props are cheap. That's an easy thing to take a look at, and they really make a huge difference in the amount of vibrations you see on your gyro signal mechanically. Again, coming back to this, looking between the amp draws and the vibrations you see, and if there's any correspondence there, that's usually electrical. If you don't see that correspondence, then it's probably just a mechanical vibration. When it comes to mechanical vibrations, you're trying to see if there's a correlation between when I drop the throttle, do the vibrations go away? Even when I'm doing hard moves, up and down, left and right, yaw moves, at 0 throttle, you shouldn't see a lot of vibrations because the motor should be spinning fairly slowly. They're spiking up to actually, enter and arrest moves, but there's also stresses on the frame that are kind of dampening out some vibrations just by that torque stress on the frame itself. So now that we know the differential between electrical noise on the gyro and how we can pinpoint that versus some mechanical noise that maybe doesn't look that great, what does good mechanical and electrical look like on a quad, and just a couple different quad classes. So let's look at something that looks really good. So this is a Transtech. This is my DJI quad that is a 5-inch. You can see I also have the Expo on here, raw. So this is all the same amplitudes and stuff. And you can just see the difference in vibrations on this. How, you know, they're there, but they're not nearly as much amplitude. You don't see as much red in your face. And, you know, I can just scrub through this whole thing and you're not seeing, you know, big issues. Obviously, when you're looking down here, you don't look so much at the P&D because that really matters how much P&D gains. Just be looking really at the raw vibrations up here at the top between roll, pitch, and yaw. And I can just scrub through this entire thing and you can see, you know, there's some spots where there's vibes kicking up, but this is a really good quad, flies well, and vibrations on it are really good in my opinion. So that was a 5-inch. This is a 2.5-inch toothpick. This is an Avant Nano quad that I did a review on. Again, same thing here, looking at these top traces up here. You can't even really see the red lines. You know, they're there, but it's nothing, you know, really bad. Again, a really good smooth flying quad. You can see we do get into some here. And, you know, this is what I would look for. You know, I see something like this, the first thing that goes in my head is, yeah, raw vibrations on this quad are in good shape, especially when you can hardly see the red behind the green set point, which is where the sticks are commanding the quad to be. You know, some spots, yeah, of course it comes up, but it's not like it's predominant. You know, this is even 100% throttle. You can hardly see any vibrations there, so that's pretty good. And finally on this one, this is a 6-inch 12S quad. This is the same quad to match the build that Nerk did, a 12S, and I might have a video on this a little in the future. But again, here, especially for a 6-inch and especially for a 12S, the mechanical vibrations and electrical on this look really good. Not that surprising since the ESCs or the APD ESCs, which have a 250 microfarad capacitor on each individual ESC, which is on the arm, which obviously is the best way to go. Again, so you're not seeing any electrical, and mechanical is nice and sound on this as well. Notice the Expo is on, and yeah, it's just kind of scrub through this so you can see, you know, the red lines up here, and you can see that, you know, in some cases, again, you can see it coming up when we're having, you know, like prop wash conditions, things like that, full throttle punches. But in most of the scrubbing through this log, you really don't see a lot of mechanical vibrations or any electrical weirdness popping up with jagged lines and things like that. You know, specifically here, this is a 100% throttle punch here, you know, very low mechanical vibrations showing right through here. Okay, so that is it. Hopefully with that you can tell the difference between electrical noise on the gyro versus mechanical noise, and have some examples of what's bad, what's okay, and what's good in regard to electrical and mechanical noise coming from the gyro signal. As always, thank you everybody for your continued support, and I hope this helped.